The purpose of the activity that we're going to do today is to find the relationship between horizontal position and time and vertical position and time for a projectile. Listen, we know the path of a projectile is going to be a parabola. And we know what the relationship between horizontal position and time is and vertical position and time is already. Essentially what we're going to do is verify that relationship, right? We know that horizontally it should be constant velocity and vertically it should be acceleration. We want to see that. We want to see that. So how are we going to do this? This one's going to be different. You're not going to use a motion sensor for this activity. You're not going to use a SparkView app. You're not going to connect anything to your iPhone and so on, but you are going to use your phone. Today what you're going to do is video the path of a projectile going from the left side of the screen to the right side of the screen. So start with a ball over here. Throw the ball, literally, out of your hand, while somebody else is standing back away from the situation and videoing it, holding the camera as still as they can. That ball is going to go up like this, and it's going to come back down like this and strike the ground. I want you to make sure when you're videoing this that the entire path of the projectile is in the frame of view of the video. So if you happen to video it and the ball happens to go out the other side like this because you threw it too hard, do it again. You only need one trial, but it's got to be a trial in which you can see the entire parabola, the entire path of the projectile in the screen of the camera. Now, don't just say, oh, I'll make sure I get it right on the first try and throw it like this. We want it to take up a good portion of the screen, but we don't want it to go outside of the screen. All right, so how are you going to do that? How are you going to analyze the data there? Well, the first thing you got to do as you're videoing it is, of course, to make sure that the entire projectile's path is in the frame of view of the video, but you also have to make sure that somebody is standing over here with a meter stick. Somebody has to be standing in the video with a meter stick. You're going to use some computer software in a little bit in order to analyze this data. And you need to tell the computer what a meter is. The computer knows what a second is already based on the frame rate of the video. But the computer doesn't know what a meter is. If you're standing further back, then a meter looks different than if you're standing close up. So you're going to tell the computer what a meter is. And the way you're going to do that is by putting a meter stick in the video. All right? You need at least 3 people here. Somebody to throw the ball, somebody to hold the meter stick, and somebody to be videoing this. A 4th person might be good to kind of coordinate the whole deal as well. Okay? There's your video. Then what do you do with that video? Well, you're going to email it to yourself, okay? Emailing it to probably all of your partners, although in the end, you're going to do this as a group, so as long as one person receives the video, that's okay. Once you get that video received in your email, the process of analyzing it ends up being quite a bit easier than the process of exporting it and importing it with the SparkView app was. Okay, you're going to get that video, you're going to check your email on one of the laptops that we have in the computer here, not the Chromebooks, but the PC laptops, and you're going to save that video to the desktop. Forget about the Google Drive and all of that stuff, just save the video to the desktop. Got it? Then you're going to open up some software called Tracker software. And you're going to follow the instructions that appear on page 12 of these booklets to use the Tracker software. Now, the instructions in this for the Tracker software in this booklet use 2 objects. You're analyzing 2 objects. Obviously, all you're going to have to do is select one object. Instead of 2 objects, you're just going to do one of them. So it means it's half the work for you guys. You're going to end up getting a data table in that Tracker software when you analyze this data. Data table that looks something like this: time, horizontal position, and vertical position. You're going to copy and paste that data into a Google Sheet. One Google Sheet for the group of you. So if there's 4 people in your group, there's one Google Sheet. Got it? You can share that Google Sheet so everybody can be working on it, but one Google Sheet. Then we've got to do an analysis. The analysis is simply going to be horizontal position versus time, and vertical position versus time. Your horizontal position versus time graph is going to be a certain shape. I'm not going to tell you what that's going to be right now. You can make a prediction on that, and hopefully you get that shape. Your vertical position versus time graph is going to be a different shape. All you're going to do, once you have your data and your two graphs plotted, is conclude something based on those two graphs. Remember, your problem was to find the relationship between horizontal position and time, vertical position and time. All you're going to do now is say the relationship between horizontal position and time is blank. It's constant velocity. It's accelerated motion. Whatever it is, I know this because blah, blah, blah. The relationship between vertical position and time is blank. I know this because blah, blah, blah. Make sense? And then, of course, your sources of error.